So for a second example in 8.4, we're going to solve the following system by finding the inverse of the coefficient matrix, A inverse, and using it to solve the system. So let's take a look at that. The first thing that we need to do is we need to write the vector formulation. So what is our vector formulation here? Well, that's the coefficient matrix, A, which in this case is going to be 3, 0, 4, as there is no y component in the first equation. The coefficients on the next equation are 2, -1, and 3. And in the third equation, the coefficients are 3, 2, and -5. We then have to multiply by our variable vector, which in this case is the variables x, y, and z. So that's our x vector. And this will be equal to our constant column b, which is the right side of all of our equations, 0, 1, 0. Now recall that we can solve this system, provided A inverse exists, by multiplying both sides on the left by A inverse. In fact, let me go over that again one more time. If AX is equal to B, then we can multiply both sides on the left by A inverse. And this will become the identity matrix times X is equal to A inverse times B. The identity matrix times X is just X. And so if we can find this elusive inverse matrix, we can just multiply it by our constant column, and we will have our solution. Now, in order to find our coefficient matrix, recall that to find A inverse, we use the algorithm 1. We start with A and the identity matrix of the appropriate size. 2, we use EROs until that matrix becomes the identity on the left and A inverse on the right. And then 3, we strip A inverse out of that construct, and then we use it and multiply by the vector B, and that should give us our answer. So let's get started. The algorithm and part 2 can be a little bit long-winded. Let's get started with that. So I here will be the coefficient matrix, 3, 0, 4, 2, -1, 3, -3, 2, -5, with the identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1 on the other side of that double wide matrix. So there's our AI, and now we're going to do some elementary row operations. And what we need to do here is we need to find our pivot in our first row, which is the first non-zero value, which is 3. And we can use that position to eliminate the positions below. Now, what I'm going to do actually first is, ideally, I'd like this to be a 1 in this position. So the first row operation that I'm actually going to do here is going to be row 1 minus row 2 is my new row 1, because 3 minus 2 is equal to 1, and that'll give me a 1 in that position. So 3 minus, let me do that in red here. 3 minus 2 is 1. 0 minus -1 is also 1. 4 minus 3 is 1. 1 minus 0 is 1. 0 minus 1 is -1, and 0 minus 0 is 0. And that is the result I get from that operation. So hopefully we're practiced enough that I don't necessarily have to write out that one. That one's not too overly difficult. This next one is 2, -1, 3, 0, 1, 0. I haven't done anything there. And since the blue 3 at the top and the -3 that's red at the bottom are the same but opposite in sign, I'm just going to really quickly add those two together. So row 1 plus row 3 is my new row 3. And if I add the top to the bottom, the top 3 plus the bottom negative 3 is going to be 0. The top 0 and the bottom 2 is going to give me 2. The top 4 and the negative 5 will give me negative 1. The top 1 and the bottom 0 in the next column will give me 1. Top and bottom zeros added together will give me 0. And top 0 plus bottom 1 will give me 1. So I'm almost done clearing out that column. I still have my main, still have my main pivot in that first position. And I am still trying to zero out this position below it. So let's do that in our next step. This is row equivalent to, that won't change, top row 1, 1, 1, 1, negative 1, 0. The bottom row will not change, 0, 2, negative 1, 1, 0, 1. And we're going to do twice row 1 minus row 2 is our new row 2. And I'll actually write that one out. Twice row 1 is 2, 2, 2, 2, negative 2, 0. The middle row is 2, negative 1, 3, 0, 1, 0. And we're going to subtract row 2. That'll be my new row 2. And 2 minus 2 is 0. 2 minus negative 1 is 3. 2 minus 3 is negative 1. 2 minus 0 is 2. Negative 2 minus 1 more is negative 3. And 0 minus 0 is 0. So our middle row is 0, 3, negative 1, 2, negative 3, 0. Okay. So once we're done with that, we want to move to our next row. Now that we're done cleaning out these two positions, using that pivot, we want to move to our next pivot. And if I can get that to be a 1, that'd be great. I also want to clear out that position below it. So let's see, we're probably going to do 2 operations here. We won't do them all in one step though here. Let's see. Again, I could just multiply. I could do something like 1/3 row 2 is my new row 2. And that would give me a 0, a 1. But then it would give me a negative 1/3, 2/3, negative 1, and 0. And I'd be messing around with fractions as I do more and more row reduction. So I'm going to avoid that. Instead, what I'm going to do is I'm just going to do row 2 minus row 3 is my new row 3, because 3 minus 2 is 1. So instead of using multiplication, I'll just use subtraction, and that will give me the 1 in that middle position that I'm looking for. So the top row is 1, 1, 1, 1, negative 1, 0. The bottom row is 0, 2, negative 1, 1, 0, 1. And as we do the middle minus the bottom, middle row minus bottom row will give me 0, 1, 0. Oh, that's nice. 1, negative 3, negative 1. So it was a pretty easy manipulation. And I now have 1s in my leading pivot positions there, my leading 1 positions. And then I still have those 0s, but I need to 0 out this 2 position. So let's do another row operation here. The top row, 1, 1, 1, 1, negative 1, 0. The middle row, 0, 1, 0, 1, negative 3, negative 1. And in the bottom row, I'm going to do twice row 2 minus row 3 is my new row 3. So twice row 2 is going to be 0, 2, 0, 2, negative 6, negative 2. Row 3 is 0, 2, negative 1, 1, 0, 1. And we're going to subtract there. And that's going to be my new row 3. And 0 minus 0 is 0. 2 minus 2 is 0. 0 minus negative 1 is a positive 1. 2 minus 1 is also 1. Negative 6 minus 0 is negative 6. And negative 2 minus 1 more is negative 3. So this will become 0, 0, 1. 1, negative 6, negative 3. Now, remember that I have to have the identity on the left side, so I have 2 more positions I have to eliminate. I should have maybe stated this before. I could have actually up here also eliminated that position above the 1, and I kind of forgot to, but that's okay. We'll go back and get it right now. We can do that in any order, as long as we're moving with the correct pivots there. So that's my result. Now, let's go ahead and zero out that position above right now. So we're going to use this pivot, and now we're going to clear out that position up above as well. So this will be row equivalent to, the bottom row is not going to change, 0, 0, 1, 1, negative 6, negative 3. The middle row is not going to change, 0, 1, 0, 1, negative 3, negative 1. But we are going to take row 1 and we're going to subtract row 2. And that's going to be our new row 1. So that should be easy enough. Top minus middle, 1 minus 0 is 1. 1 minus 1 is 0. 1 minus 0 is 1. 1 minus 1 is 0. Negative 1 minus negative 3. Be careful there. Negative 1 minus negative 3 is a positive 2. And then 0 minus negative 1 is a positive 1. So that should be our result there. And now we are done with the following. Let's see here. We had, we had our pivots, and we got our ones down our diagonal. We had cleared out the following. Cleared out that spot, that spot, that spot, that spot. We need to clear, this one's already 0, but this is our problem right there. So this needs to be 0. So let's keep going. Not sure why I chose to annotate that one specifically, but there it is. So this will be the bottom row, unchanged. The middle row, unchanged. The top row, though, we're going to do one more operation. Now, in order to clear out this one position, we're going to use this blue pivot to do it. So we're going to do row 1 minus row 3 is my new row 1. So top minus bottom. As we do that, the top minus bottom will be 1, 0, 0, negative 1. 2 minus negative 6 is a positive 8. And 1 minus negative 3 is 4. And so now we have that form that we're looking for. This is the identity matrix on the left, which means that this is our inverse matrix on the right side. So A inverse is equal to negative 1, 8, 4, 1, negative 3, negative 1, 1, negative 6, negative 3. This particular inverse didn't have any fractions in it like we saw yesterday. This one was a little bit cleaner. And now we have to use it. Now, use it. So this is going to require some matrix multiplication. X, our solution, which is the variables x, y, z, is equal to A inverse times our B column. So we have our A inverse, negative 1, 8, 4, 1, negative 3, negative 1, 1, negative 6, negative 3, assuming we haven't made any mistakes, times our B column. And if we go back up here and look at our B column was 0, 1, 0. So let's put that back down here. Times 0, 1, 0. So this should be pretty easy to multiply out. This is a 3 by 3 times a 3 by 1. So these inner dimensions match up. So since these are the same, the product is defined. The result, though, is going to be those outer dimensions. So this should be equal to some kind of 3 by 1, where the top row is the product between the first row and the only column in B, which is -1 times 0 plus 8 plus 0. So this is going to be 0 plus 8 plus 0. Maybe I'll write that out for the people that are watching or doing this for the first time. Where am I getting that? I'm taking this value times this value, which is -1 times 0, plus this value times this value, which is 8 times 1, plus this value times this value. I'm trying to figure out different ways to annotate those. Plus 4 times 0, and that is going to give me just 8 in that top position. Doing the same thing and moving across the bottom, we see that we're going to get 1 times 0, which is 0, plus -3 times 1, which is -3, plus another 0. Oops, I don't know why I'm writing that there. In a similar fashion, we'll get 0, -3, 0 minus 3, plus 0. And in the bottom, we'll get 0 minus 6 plus 0. So the result is 8, -3, -6 is our solution, which means that x is 8, y is -3, z is -6, or 8, -3, -6 is our ordered triple that satisfies that original system.